Good afternoon. Is this working? Good, because I cannot tell. If I'm being too quiet, if anybody in the back is not hearing me mumbling, please just raise your hand and wave it, and I will start yelling louder. Okay. Well, we were a little bit bewildered last year when a bunch of us showed up at the fourth day for 2009. We had been led to believe that our circumstances would be a lot better than they were at that time by then. However, this year we are better off, and so we're going to come with a little bit more cogent presentation, we hope. In the course of this afternoon, I'm going to sit here and yak for a while about what's going on with green arrays and what our plans are and what we're up to. And then an assortment of our folks, including Michael, who is kind enough to stand amongst us because he is our good buddy and we love him. We'll also be yakking about applications, development tools, and use of these wonderful chips that we're in the process of making. And we will time all of this carefully so that Chuck's Fireside Talk starts right at 4 p.m. so that there is no delay in getting to supper. Fair enough? The break will be after Michael and after Jeff. Last year, we had successfully done a number of things after we were dumped unceremoniously on our butts by a gentleman named Dan Leckrone. Dan Leckrone is the sole and exclusive owner and in absolute control, as far as I know, of an outfit called the TPL Group, which now has a skeleton Potemkin village running on the net called Intelisys. As far as I know, nobody works for Intelisys, right, Michael? You actually work for TPL? Is that correct? Okay. So Intelisys doesn't actually exist. I learned recently that Intelisys also has no chips. It appears that Intelisys, in its infinite aplomb as a chip manufacturer and selling agency, lost all of its chips. They left 16,000 completed S40s in a cabinet when they moved out of their old building, and it did not occur to anybody that it might be important to know where the heck their chips went. So they vanished. Also, 10 wafers that would have translated into 33,000 more S40s were thrown into the dumpster at Amcor in Korea because apparently no one from Intelisys had bothered to stay in touch with that outfit that they were in the process of stiffing for the money that they owed them for packaging the first 3 or 6,000 chips. So in theory, maybe they've got a couple more wafers of them, but at any rate, we were unceremoniously dumped on our behinds. And all of us were then trying to run a company. We tried to spin out from TPL. That failed. The negotiations were not, in our opinion, in very good faith. And so from February of 2009 until we came here last fourth day, we had been happily making shuttle runs. We got involved with a new foundry in Singapore that's a lot cheaper and no worse than TSMC. I would recommend that anybody that wants to make chips talk to Global Foundries, not to TSMC unless you have a lot of money. We had made a 32-node chip to calibrate the foundry and to run calibration circuits. We had made a 130-nanometer chip. We'd made a chip with 5-volt I/O. We'd made the first cut of the GA4, which has new computers and new I/O pads and a lot of redone I/O circuitry. And we were waiting for the first cut of the 144 and the second cut of the GA4 as we came and visited last year. We were also broke. We had been spending all year looking for venture capital funding. We had been representing ourselves as a single application company. Not bad applications, but we couldn't show any application partners because we didn't have any. And so the VCs were not terribly impressed. We had learned that this doesn't work, and we also had come to the suspicion that we really didn't want it to work because VCs tend to come with their own agendas, their own management, and their own exit strategy. And here's the problem. For the last 25 years, Chuck has been trying to get chips into people's hands. Who, besides me, has tried to buy Novix chips from Novix? Anybody? I gave him a PO for 100 chips. I was willing to write him a check the next day for 10 grand for those 100 chips. They refused to even acknowledge that I had asked them about anything. Then Chuck and one of my customers and I went and proposed to Novix that we would fix the interrupts, we would fix the divide issue, and we would do that gratis as long as they allowed us to order chips from Mostek at cost. and give them a 15% spiff off the top. No, 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 they didn't want to do that either. It's been that way ever since. With the sole exception of Harris and of Dr. Ting, nobody has put more than a handful of Chuck's chips in anybody's possession that could do anything useful with them. I was ticked. At the time that the Novix chip was first out, I had a customer in Detroit, the Chrysler Engine Development Group, who were all excited about doing mass fraction burn curves in real time. It turns out that you can do best power tuning cylinder by cylinder if you bother to do that, and all it takes is a relative pressure transducer. We could have thrown a load washer under each spark plug in a gas engine and a Novix chip behind each cylinder and had that engine running at max power all the time under all conditions, no matter what fuel, no matter what air, no matter what humidity or any other conditions were happening, and they were jazzed. They wanted to do it. I could not get chips from Novix to do that with. I wanted to build a combined GPS receiver and ELT transmitter that knew what the ephemerides of the satellites were, the Russian satellites, which are the only ones that listened for ELTs at the time. I couldn't do that either because I couldn't get Novix chips. 25 years later, we still can't get Chuck's chips. Green Arrays exist to stop that situation from happening. And either we will turn out some nice, significant products or we won't. But it beats working for those bozos, the guys with the inflatable shoes and the frizzy orange hair and the red noses. You know who I'm talking about. Okay, so that is our agenda at Green Arrays. We're going to demonstrate that we're a real honest-to-God chip company. We are not going to compromise by taking money from somebody who's going to turn us into a flip or sell us to a competitor that wants to annihilate our products. How many here have lost customers that were sold to their competitors? Okay, it's no fun. So, reality, credibility is our goal, and we have been spending the last year trying to establish ourselves on a more credible basis. We reconfigured the company so that we could reasonably bootstrap it if we had to, without any significant influence of capital. The first step that we took was to distribute the ownership. We had, last year at this time, been solely owned by Chuck. Now we are entirely owned by our founders, which is every man jack that was working on this project together. We also have put up a genuine SEC-registered Regulation D private placement so that we can legally sell stock. We have to sell it to rich people, or at least people that have $1 million of net worth or have $200,000 of annual income and can document all of that. We're selling stock to such people in blocks of a minimum of 100,000 shares at $1 a share. We valued the company at $10 million, which we believe is reasonable given where we're at, what we have working, and what kind of a team we have. So our goal at the moment in terms of external funding is to raise up to $5 million from people like that to stabilize us for a period of maybe 3 years until we're profitable. And that assumes that we're not fortunate in getting any significant application hits, which we think we will. The commitment to reliably supply chips is a definite chicken and egg problem. And fortunately, we were able to raise a couple of $100,000 from a good old honest-to-God businessman, a real honest-to-God manufacturing person in the Midwest who has run his cardboard box factory with a fourth system for the last 30 years and has not needed to update it or anything else and is very pleased with that. So he had no problem at all in making a small investment out of his family trust toward our going somewhere. And since we have not got anywhere near enough money out of that to pay ourselves still, we went ahead and decided to commit it to instead making a production run, so that we could now talk to somebody who might have a product that he would like to build out of chips like these and say, yes, I will take your order for delivery in June or later of 2011 for any quantity you would like to order. Okay, I will give you prices that are good based on a real honest-to-God industry standard experience curve, not on some bogus, I want $30 a chip in quantity 100,000s, the way certain other people do. We need to be in that position in order to actually find the applications, because only a smoke and mirrors guy would buy into claiming that he was going to make something out of a chip nobody could deliver him even evaluation quantities of. We have to be in the position to deliver chips. And so that's what we are doing, and that's what we have begun doing. The wafers, as of last night, we're still waiting for the first mask to get to Singapore from Hoya, It should have arrived, and so they should be running the first masks today. We'll have wafers out probably on the 10th of January. The wafers will be shipped to the packaging house of our choice, and we should have parts back to test mid-February. We are in the process of building our own test fixtures. We don't have the money to make regular Teledyne-compatible 4-socket test fixtures, so instead we'll prototype the ones that we're actually going to make. They're going to be a novel sort of test fixture. In order to keep the testing cost down, so it only costs us about a dime to test it at GA144, we're going to put 2 of our chips around each socket on the load card for the tester, and all the testing will actually be done by our chips. All that we'll use the tester for is a power supply, start signal, and somebody to report the answers to. And we'll just tell it, good bin or bad bin, and here's some numbers to log in your log file. And the numbers will be statistics that we are interested in measuring that month. So at any rate, we are building a half a dozen of these prototypes of 1 socket worth of a load card. We will then sit down and manually test the first 20,000 chips. We figure this will take us 3 or 4 days with 6 people, 8 hours a day, running manual load cards. We can test 2 chips a minute that way per person, and it works out. So we'll have a good time doing it, and we'll have 20,000 tested chips, hopefully not too many failures, and we'll have statistics on some of those. That's the goal. That's where we're headed. So our configuration is that we are a genuine C corporation with stockholders. The ownership I've discussed, the PPM I've discussed. Our operating expenses are nil, so we can actually survive well into next year. In fact, well past the middle of next year without actually finding another investor. If necessary, we will try and sustain ourselves based on actual chip sales. And it doesn't take all that many chips being sold to actually start paying ourselves. And if we have to do it that way, then the investors can cry in their beer that they didn't have the opportunity to participate. One of the parts of our plan that is very important is, in fact, mobilizing the fourth community, such the fourth community are interested in being mobilized. There are companies, there are individuals who can do a great deal both for themselves and for us by advancing this cause and promoting the use of these chips in applications and helping people to get them into applications. We are interested in encouraging and cooperating with anybody who's interested, talent, and skill to do this. Tons and tons of ways that we can cooperate. Somebody who likes to port C onto things is welcome to port C or Fortran or BASIC or any other favorite programming vehicle of choice onto a virtual machine that's running on, say, an GA144. We are quite willing, since we can't afford to pay for that, we're quite willing to collect for that person whatever they want to collect per copy of their software and deliver all the money to them. We don't need to make a cent out of that. We're quite willing to let whoever is willing to do the work on spec make all the money from it. So that's a thing to pass along to your buddies who might be underutilized and interested in porting languages. There are tons of other ways that we hope to be able to provide useful, gainful entrepreneurial opportunities to members of the fourth community, and let's not forget to bring those up. If you have any thoughts about some, please contact us. We've yacked about these chips a whole lot, and I'm not going to spend a bunch of time now trying to describe and characterize them. We've actually got pretty decent documentation up on the website. There are not only the product briefs, but there's now a fairly extensive discussion of the computers and of the I/O. There is one going together, which will be a full-up data sheet on the chip itself, including package drawings, pinouts, better engineering numbers than we have there, and of course all those will be improved as we actually get the chips tested and have more statistics to include in the tables. Probably our biggest single asset, other than Chuck's attitude about how to do things, is his OCAD, which we've all been working on improving, stabilizing, refining ever since we got involved with him on this current iteration. OCAD is invaluable. Ordinarily, it costs a couple of $100,000 a year minimum per guy to have somebody designing silicon. A crew of 10 people is a very expensive proposition for the regular industry as a whole. For us, it doesn't cost squat. We are proposing to actually take high school kids that are bright and teach them to lay out silicon. I believe that's possible because, well, I haven't had to use any electronics I didn't know in the 10th grade yet. Ohm's law and knowing what an RC time constant is gets you a long way in digital silicon layout. The architecture is amazingly portable. Last estimate is about 2 man-weeks to lay out a new configuration of existing nodes and existing I/O components with a particular desired pin-out, desired configuration of I/O. We can make custom chips pretty cheaply, so the plan of presenting the 144 as the ultimate prototyping platform and first out product device to be followed if you have a product that needs to have its costs cut with customized chips that have no more on them than necessary is perfectly feasible to do. The ante for something like that is something less than $100,000 for a set of masks, and once those are made, the wafers are dirt cheap to crank out. So it's not an unattainable goal because we don't have to throw millions of dollars of NRE onto the front end of that for the design effort. We are pitching the 144 and all of our other potential chips as suitable for every embedded application. There is no particular niche. The applications that stand to benefit the most are the ones that need some combination of low power, low energy, high performance, small size, or low cost. But there's no reason in the long run why one cannot use our chips instead of anybody else's for embedded applications. We intend to price them aggressively enough that they're attractive for this sort of thing. We will have chips shipping in Q2, we've said, and we're fairly comfortable with that given that we've given ourselves like 6 weeks to do the testing. We've been taking advance orders on the website. We've sold over 300 144s. We've sold over 25 evaluation boards so far. And those are the people that want them badly enough, some of whom are in the room, that they're willing to put up 50% of the money up front against our word that it's going to be a worthwhile device that they get, because we don't have a definitive description of either one of those things up there yet. I think that's very encouraging, and we are not going to let those people down at all. We have been generating documentation as fast as we can and posting it on the website. Nothing that we have requires an NDA. Nothing that we're going to give anybody that you need in order to program our chips is going to require an NDA. There's no bubble pack agreement like Intelisys is that says that they own the code you write. And we're trying to raise money. If you know any people that meet those criteria for accredited investors, please send them our way. It would be nice to get paid. That's really what we're trading off. Without the help of investors, we're still going to all have to work for nothing. And the longer we work for nothing, the less inclined we're going to be to share it with anybody else once we've got it. The 144 I'm not going to waste your time with now because you can go get it off the website. And if you have any questions after reading our documentation, just call in and ask. The evaluation board is still in the process of definition, but at the very minimum, we want it to have 2 chips on it. There's a reason for that. The chip on the bottom is the one that you talk to. And you're going to be able to talk to it multiple different ways and program the heck out of it. It has so many of its pins committed that there's very little left that you can experiment with them in the terms of I/O. 40 of its pins are busy talking to an external static RAM. 4 more of its pins are busy talking to an external SPI flash. 2 of its pins are busy talking to a PC or whatever you're using to program it with. We will have all the rest of the pins of that one brought out on headers, and there will be a way to attach things to them. But it is the chip for a programmer to be interested in. The top chip up there is the chip for somebody that's interested in prototyping hardware to be using. He has no more pins committed than are absolutely necessary in order to be able to get code into it. All of his parallel pins are available. Most of his serial pins are available. All of his general purpose pins, except for 2, all of his A to Ds and DACs are available. We are not planning to load those guys down even with headers. What we're going to do is bring out hole patterns, at least that's the proposition at the moment, on the board, unpopulated hole patterns, to minimize the parasitics that we've loaded down all of those pins with, and provide the headers in a package so that if you want to connect things up to them and don't mind the ludicrous capacitance and inductance of the header, then you're quite welcome to go ahead and solder it in. It's much easier to solder one in than to unsolder it. That is a hardware guy's chip anyway. We figure that's probably a good trade-off. If you don't think so, let us know. The minimal RS-232 transceivers that we're going to put on there are an illustration of Chuck's philosophy. They're going to consist of 2 N transistors and 4 resistors. And that's it. 2 pull-ups for the Ns. The Ns are powered by one of the RS-232 handshake lines coming from the other guy. And we have one more RS-232 handshake line going through a series resistor to be reset. And that's it. So you're not going to find a level shifter and an inductor there because we don't need them or want them. And no, it won't talk to a bipolar receiver, but I haven't seen one of those in decades. If anybody has, let me know, please. One that actually insists on negative voltages. No, it's whatever you, the alleged RS-232 interface gives us. If it gives us 12 volts, okay, we'll give it back however much its supply of 12 volts will allow us to give it back after it goes through a dropping resistor, through a series resistor pull-up. Okay. Again, any RS-232 receiver that insists on seeing minus 3 volts, it will not work with. But again, I don't know if I still own one. And I own a lot of old stuff. Any questions about that before I move on? We'll have a much more complete description of this board up on the website just as soon as we actually decide exactly what it's going to look like. What we think are the special things about these chips and what is going to be emphasized in every app note that we can produce are the exceptionally low energy per unit work, way lower than, say, an MSP430 that's touted as being a micropower controller. We are factor of 30 less energy used than an MSP430, and that's assuming that it's running out of RAM, which it never does. It's running out of flash, so call it 60. The instant suspension and resumption, the going into the deepest sleep we know how to do in a matter of picoseconds and coming back out in a matter of picoseconds is unique and special. Most of these other devices take a considerable amount of energy to shut down and to speed and to start back up again. The performance is not shabby for a chintzy little node such as ours is. And the performance, by the way, is one of those things that we would lose if we enlarged the memory. It's something that we would lose if we made the ALU wider than 18 bits. It's something that we would lose if we did most any of the things that we hear most often as suggestions. One of the things we couldn't do is make a big computer. We couldn't make a Shaboom or a MUP21 and keep that performance level simply because the capacitance of the bit lines would get too big. We wouldn't be able to drive everything at a speed like that. Everything costs. It's one of the things that a principle that's used when proposing a change to Chuck is that if you make the processor simpler, if you remove something and can still add some new functionality, that's a cool thing. But you have to make less of something to make room for the more of something. The small size is pretty nice, less than half a millimeter wide, well, less than a quarter of a millimeter wide, less than a half a millimeter long is what one of our nodes looks like. The cost of the silicon there, if you're not paying too much overhead, is less than a penny per computer, basically. Software-defined I/O. At least 1 or 2 people that have contacted us with real honest-to-gosh applications have realized the importance of this. Being able to actually produce a high-speed, bit-banged interface is a unique thing in these computers because only here do you have a whole computer to burn keeping track of a pin. You know, elsewhere you don't have that luxury. If the machine's fast enough, it's too important to burn it on such a stupid thing as keeping track of a pin, but we can. Multi-level programming, what we mean by that when we say it is that you can write straight machine code for the node, and it runs really fast at these speeds. You cannot put TCP/IP in one node. You can't put a whole lot of things in one node. The node is there to do a defined function. He's a function block in a flow diagram. Think of it that way. And if you can define a function that's simple enough to write in a maximum of 256 opcodes of RAM or 256 of ROM and a bunch of RAM code or RAM data, great. But regard it as a function block. Regard the flow diagram that is being implemented at real time at high speed by all of these simple little processors that you program in machine learning. We have a next level up. If you have a source of data you can stream into the chip fast, you can execute out of a COM port at not that far off of machine speed instructions that are fed through the COM port. Basically, it's a 4-to-1 ratio already in terms of opcodes. And so if we can fit external memory, stream it into the chip at 4 times the time of an on-chip or an on-node RAM access. We haven't slowed it down at all, and we're streaming code in through the port. In practical reality, you'd slowed it down some, but not more than a factor of 10. So there's a way to run an arbitrarily long program still as an F-18 computer, but without the code being stored in memory, getting it from a neighbor. There are tons of ways to do that, but one of them is that the feeder has to have some interaction with the compiler to know how many consecutive instructions without a branch to feed in before getting word back as to whether to make the conditional branch or not. Charlie has monkeyed with this a lot. The third level of programming is some kind of virtual machine, at least the third one that's obvious to us, and there's probably a bunch more ways to go about it. A virtual machine, as we're going to talk about it, John's going to discuss how the RAM model works for external RAM. But the basic idea is we got a 5-node cluster that controls an external memory and presents a dual port memory interface inside the chip. And there's 2 COM ports that other nodes can talk to the memory through. We have an eForth implementation in 2 nodes that tacks onto this 5-node memory controller. And that's it. That's all the eForth virtual machine takes. The rest of it's outside in RAM. Big RAM. And so that's a challenge for anybody that has a favorite programming language. If you want to implement it, see if you can beat the 2 nodes that eForth takes. While we are getting these chips into production and delivering them to people in the second quarter, we have a plan for continuing ongoing development. And we do have enough budget to be able to make a shuttle run or 2 before we go broke. So we are going to explore an ultra-low leakage process at our favorite foundry. Presently, each one of our nodes is consuming a princely 100 nanowatts when it's doing nothing. And this ultra-low leakage process from GlobalFoundries should take us down to 1 or 2 nanowatts per node when they're doing nothing, which is a desirable goal. We do need to finish getting our level shifters squared away so that we can run 5-volt I/O max, and that will allow us to run anything from 1.8 to 5 with no problem. We need to get that squared away. We're going to explore licensing somebody's SRAM, dense SRAM, and putting a chunk of it on the die as a peripheral. We cannot and will not ever do that inside of our nodes. Our nodes must be built out of memory that we design using the same type of transistors that we use for everything else. To drop a commodity in there would make us not portable. That's a bad thing. But talking to a big hunk of SRAM on the die beats the bejeebers having 40 pads to run, because we have to bond wires on all those 40 pads. We have to pay for all kinds of power to put charge on and off of those pads, and it all takes time. So it's a desirable thing to learn how to do and find out how much we can put there. And finally, our fab does have a license to use the Cypress Sonos process, which basically adds 4 masks to regular logic type CMOS and gives you flash. And we are definitely going to check that out because that is another one of those little things. If we had enough SRAM on board of one of our die to run, say, eForth, and we had enough flash on there to hold eForth and some application code, we could put that and a bunch of nodes onto a 3x3 16-pin QFN package. That package costs not quite, more like an eighth as much as our big package with all of the 88 pins on it does. The die costs not much, and so what we'd end up with is a chip that could be a single chip microcontroller without having to cut ROM and still way dirt cheap and still programmable at all 3 levels. I've run over a little bit, but it's not going to affect things too much. Next up is going to be Michael, who is going to regale us with his totally awesome application. To set the tone as to why it's worth bothering making these puppies, Jeff is going to come up and give a pretty darn good and comprehensive overview of how we have been developing software using ArrayForth, which is what we are going to be providing for the foreseeable future. Then we're going to take a break. Charlie's going to come up and discuss his simulator and test beds, which everybody can get right now from the website and pay nothing for and use the bejeebers out of, do whatever you want. Simulate a 144, get all the code you like working. Jeff will come back and talk about the code which is conveniently sitting there in ROM now and which is available for use. John is going to discuss our architecture for addressing external memory. Stephen Su, who has been our most prolific author of test software, both in simulation and on real chips, is going to explain what he does and how he does it. And if we have time, there's lots more useful, cool stuff we can discuss. Any questions before we get rolling? Sir?
I just wondered that with a chip that's as different, as advanced as you have, is it enough for people to take the way that they're consistent to go over your chip?
Depends on whether they need unobtainium, which is essentially what we're offering them. And those are the best customers up front. Those are the most desirable. I don't expect that the whole world is going to wind up writing Forth code, but the whole world doesn't necessarily have to. There are a lot of people who might like to have something that runs C and has all of these accelerators conveniently there on the chip. And, well, again, that's a problem for somebody else right now because I don't have a $200,000 check to write to somebody to port C onto the box, which is the going rate. You're describing a thing that I haven't learned enough about yet called chasm theory. I know we'll find early adopters. Whether we can make it to the mainstream is kind of dependent on whether we're competent at crossing that chasm or not. But at the very least, we have to get far enough to try before we know the answer.
I wanted to point out that Nash's handouts are in the back. So if you missed his talk, I know I did. You can look at the handouts in the back on paper, or later, if you put them on the web, by giving you the name, they'll be part of the record of this meeting. And I recommend that you all have a look at the website. The other thing I wanted to ask is how many of you will be joining us for dinner at Suhong Restaurant in Menlo Park? A 1, a 2, a 3, 4, 5, a 6, 7, 8, 9, 10, 11, 12, 13, 14. Let's call it 18. Did anybody else count besides me? Okay, then you're stuck with my answer. Jason's back there, yeah, he's in.